Okay, method of Lagrange multipliers. Basically, this technique is used for finding the critical value of a function f subject to a relation on the variable x, y, and z. So basically, in the previous session, we have already seen how to find the critical value. Yes, to figure out the maximum and minimum. Uh, Now here the additional twist is that we have to make sure that we find the critical value subject to a particular condition. So let's say u is equal to f of x, y, z. Now we have to find critical value subject to the condition. Let's say phi of x comma y comma z is equal to 0. This is the condition, right? We have to find the extremums of this for this condition being satisfied. So now how do we combine these two? So let's look at the total differential. So du total differential would be ux dx plus uy dy plus uz dz. Yes. Now we also have this. So now let's figure out the differential of this. So this basically relation, we can write it as dq is equal to q phi x dx plus phi y dy plus phi z dz, and this is actually a condition equal to 0. So let us say this is 1 and this is 2. Now how do we combine these two? Let's create a new function using the technique which we have already seen. Let's take lambda times the second one plus the first one equal to 0. Now this we call it as the auxiliary function, a function combining these two. So we are creating a new function which is a combination of these two. Okay, let's expand it off. This is second equation multiplied by lambda. So phi x lambda plus ux dx plus lambda phi y plus uy dy plus lambda phi z plus uz times dz equal to 0. Yes. Now this is only possible if this is equal to 0, this is equal to 0, and this is equal to 0. So individually all of them has to be 0 for the overall to be 0. So which implies that ux plus lambda phi x is equal to 0, uy plus lambda phi y is equal to 0, uz plus lambda phi z is equal to 0. Yes. Now that means we end up with a system of equations or system of equations. Now if we solve this system of equations, we get x, y, and z and lambda. So once we solve this, we know we have got the extremum at x, y, z satisfying the given condition. Now here lambda is called undetermined multiplier. Okay, now it is all theoretical. Let's actually solve one or two problems. Find minimum value of x square plus y square plus z square subject to the condition 1 by x plus 1 by y plus 1 by z is equal to 1. So let's say our function is, we don't even have to write it completely. Let's say our function is x square plus y square plus z square, and in this case our phi is equal to 1 by x plus 1 by y plus 1 by z minus 1. We take this to the other side. Now we have to find the auxiliary function. Auxiliary function would be f. Let's say f is equal to f plus lambda phi, which is equal to f is x square plus y square plus z square plus lambda times 1 by x plus 1 by y plus 1 by z minus 1. Now we have to find the critical values. So fx is equal to, this becomes 2x, constant 0 0, lambda 1 by x, 1 by lambda as it is, 1 by x, if we differentiate we get minus 1 by x square. Yes, fy would be, rest all is same, so we can just take this as the template. So 2y minus lambda by y square. Fz is equal to 2z minus lambda by z square. Now remember, they should be equal to 0 for the critical values. So this implies that 2x cube, if we combine them, 2x cube minus lambda is equal to 0. X square, when we take it to the other side, will disappear. Similarly here, 2y cube minus lambda equal to 0. 2z cube minus lambda equal to 0. Okay, what does this imply? This implies that x is equal to y is equal to z is equal to lambda, we take it to the other side, lambda divided by 2 to the power of 1 by 3. Yes, now this is one. Now another thing that we have is the condition 1 by x plus 1 by y plus 1 by z is equal to 1. Yes, now as we have seen, x, y and z are equal, so we can substitute any one of them. So 1 by x plus 1 by x equal to 1. So which means 3 by x equal to 1, which implies x equal to 3. Yes, and since x equal to y equal to z, y is equal to 3 and z is also equal to 3. So therefore we have an extremum, or we can say that extremum can occur at 3, 3, 3, and the value of this is equal to 3 square plus 3 square plus 3 square, x square plus y square plus z square is equal to 9 plus 9 plus 9, that is 27. Right? Here we have not been asked anything else. We have just been asked find the minimum value. Okay. So which means we have found the value, but we have not shown that it is actually the minimum. It could be maximum, means what? It can be maximum or minimum. So which means we have to make sure that it is actually the minimum and not the maximum. How do we do that? We have to think of another point and show that that point is less than or greater than this point. If it is greater than this point, then that means what? That this is the minimum, because there is a point apart from this which is greater. So let's look at a point Now remember, we have this condition, so this will help us in figuring out another point. So another point, this condition. So another point could be, let's say 1 by 2, or let's say 2, 4, 4. Now how did I arrive at this? 1 by 2 plus 1 by 4 plus 1 by 4. We get 1. So at this point, what happens to our function? Let's see. X square plus y square plus z square. This would be what? This would be 2 square plus 4 square plus 4 square, which is 4 plus 16 plus 16, which is 36. Now 36 is greater than 27. That means the extremum that we found is a minimum, because there is another point which is greater, is a minimum at 3, 3, 3. Okay, let's do one more. Find the volume of the largest rectangular parallelepiped that can be inscribed in the ellipsoid x square by a square plus y square by b square plus z square by c square is equal to 1. So think of it like this. If we just say x square by a square plus y square by b square equal to 1, it is an ellipse. The moment we incorporate the third dimension, it becomes an ellipsoid. Now let's solve this. Volume of the rectangular parallelepiped, let's say V, x, y, z is equal to length into breadth into height. So here sides are x, y and z. Now we have the ellipsoid. Ellipsoid is equal to x square by a square plus y square by b square plus z square by c square is equal to 1. Now remember, we have to combine these two to arrive at the auxiliary function. So let's say that is f. This is equal to xyz plus lambda times x square by a square plus y square by b square plus z square by c square minus 1. Okay. Now to find the extremums, fx is equal to, let's differentiate, yz plus lambda 2x by a square. Fy is equal to xz plus lambda 2y by b square. Fz would be equal to xy plus lambda 2z by c square. And remember, for extremums it should be equal to 0. Right? Now see, individually they are all equal to 0. So if we add them up, then also they should be equal to 0. So let's see if we add them up, what happens. But before we add them up, here x is missing, here y is missing, here z is missing. So if we take care of that, then adding them up would give us something much more meaningful. So let's multiply this by x, this by y, and this by z. So x times fx plus y times fy plus z times z equal to 0. This is what we are trying to do. So x times first one xyz plus lambda 2x square by a square. This is the first one, plus second one is xyz plus lambda 2y square by b square plus xyz plus lambda 2z square by c square equal to 0. This and this we can add it up, so we get 3xyz plus here lambda 2 lambda 2 lambda 2 lambda are common. Yes, x square by a square plus y square by b square plus z square by c square is equal to 0. Now remember, this is equal to 1, right? This is the ellipsoid. Okay, so that is 1. So which means our equation becomes 3xyz plus 2 lambda equal to 0, which means lambda is equal to minus 3xyz by 2. Now let's take one of these and substitute lambda. So yz plus 2 lambda x by a square is equal to 0. Let's take this. Lambda is this, so yz plus 2x by a square, and here it will be minus 3xyz by 2 equal to 0. So 2 gets cancelled. So yz minus 3x square yz by a square equal to 0. Now yz is common to both. Yz times 1 minus 3x square by a square is equal to 0. This goes off. 1 minus 3x square by a square equal to 0. A square minus 3x square is equal to 0. Yes. So we have to arrive at x equal to. So let's take a square to the other side. So minus 3x square is equal to minus a square. Minus minus gets cancelled. X square is equal to a square by 3. That means x is equal to a by root 3. Okay. Now we can follow the same procedure to figure out the value of y and z. Or what we can do is take some simplified part. Anyhow, idea is this is more or less algebra. So I'll just write it as similarly. Y is equal to b by root 3 and z is equal to c by root 3. So therefore the maximum volume is V equal to xyz, which is equal to a by root 3, b by root 3, c by root 3, which is equal to abc by 3 root 3 cubic some units. Okay, I think that's enough. Bye for now.